I am now going to introduce you to a new inference rule. Fortunately, this inference rule is extremely easy to master and to apply. It is the rule of double negation. So let's look at an example. Consider the following argument. It is not the case that it is not raining. Therefore, it is raining. I think this argument is straightforwardly valid. If it's not the case that it is not raining, if it's not raining, then it must be raining. And this argument instantiates the following pattern. Not P, therefore P. We're going to introduce a rule, the double negation rule, which allows us to prove that that argument pattern is valid. Here is a statement of the rule. Whenever one has two negation signs in front of a sentence on a line, one may write a new line which contains only that sentence. And whenever one has a sentence on one line, one may write that same sentence but with two additional negation signs in front on a new line. So essentially what this rule allows one to do is whenever one finds a sentence on a line with two negation signs in front, one can delete them. Or whenever one has a sentence on a line, one can add two new negation signs. So let's look at an application of the rule. Here's the argument pattern that we just introduced. Not P, therefore P. We want to prove that it's valid. We start as usual by writing down our premises. There's only one in this case, not P. And then, via the double negation rule, we are entitled to just take those two negation signs found in front of P on line 1 and delete them. That gives us P. So we infer P from not P via the double negation rule. We infer line 2 from line 1 via DN, double negation. Okay, let's look at another example. This example is the reverse of what we saw before. P, therefore, not P. The double negation rule also allows us to prove that this sequent is valid. So we start as usual by writing down our premise, P. And then the double negation rule allows us to introduce two negation signs in front of that sentence to get not P. So we infer not P from P via the double negation rule. Okay, these examples are pretty straightforward. Let's look at a slightly more complicated example. So here is our sequent. If P, then not Q, Q, therefore not P. It turns out that this sequent is valid, and we can prove that it is valid with the rules that we have so far. So we'll start by writing down our premises. If P, then not Q, Q, those are our premises. Now we need to try to think about what we should do next. Our goal, of course, is to write down not P, and it almost looks like we could apply Modus Tollens here. We have if P, then not Q on line 1, and we have Q on line 2. Unfortunately, though, we can't yet apply Modus Tollens. And that's because, technically speaking, Q on line 2 is not the negation of the consequent of the conditional that occurs on line 1. The negation of the consequent of the conditional that occurs on line 1 would have to be a sentence that has a negation sign in front of the consequent of the conditional on line 1. So since the consequent of the conditional on line 1 is not Q, the negation of not Q would be not Q, or tilde Q. But what we have on line 2 isn't tilde Q. What we have on line 2 is just Q. So we're not able to apply Modus Tollens given what we have. Fortunately, though, we can use the double negation rule to infer from Q not Q. Okay, so now we have not Q. So now we have on line 3 a sentence that is the negation of the consequent on line 1. That is, take the consequent on line 1, namely not Q. In order to apply modus tollens, we needed a sentence that's the negation of that has a negation sign in front of that sentence. So that would be not Q. And now we've got it via the rule double negation. So now we can apply modus tollens to lines 1 and 3 in order to get not P. And that's just what we wanted. Okay, now that we've introduced these new rules, you can do a whole new interesting variety of proofs, and I'm going to give you some practice with that through the exercises that I assigned.